You probably carry a picture of the atom in your head without even realizing it. It's the same image most of us were given as children. A neat little structure, a solid center, a nucleus like a tiny marble, and circling around it, small electrons moving in perfect loops, like obedient planets orbiting their sun. It looks orderly, predictable, almost comforting. Textbooks print it. Teachers draw it. Museums hang beautiful models of it in the air, frozen in motion. It feels real, but that image is not just slightly inaccurate. It is deeply, fundamentally misleading. It gives you the illusion that atoms behave like miniature solar systems, that electrons are tiny physical objects traveling along clear paths, that if you had a powerful enough microscope, you could zoom in and point to one and say, "There it is." But you can't, because that world does not exist. The truth is far stranger than anything that picture suggests. So strange, in fact, that when scientists first discovered it, many of them refused to believe their own equations. Reality, at the smallest scale, does not behave like anything you have ever seen. It does not follow your intuition. It does not care about your expectations. And once you understand what's really happening inside an atom, you begin to realize something unsettling. The universe is not built on solid objects. It is built on something far more abstract. Let's begin with the simplest possible atom, hydrogen. Hydrogen is the most basic structure in the entire universe. Just one proton sitting at the center, and one electron associated with it. That's all. No complexity. No crowd. Just two participants in this microscopic relationship. The proton itself is incredibly small. Its diameter is roughly 1/4 of a meter. To give you perspective, if the proton were the size of a grain of sand, the entire atom would be the size of a massive stadium, which immediately raises a question. Where is the electron in all that space? Your instinct, shaped by years of simplified diagrams, wants to give a simple answer. You imagine it positioned somewhere specific. Maybe at this exact moment, it's on the left side of the atom, moving smoothly along a circular path, a tiny particle tracing a predictable orbit just like Earth moving around the sun. It feels logical. It feels reasonable. It feels wrong, because the moment you ask a deeper question, not where it could be, but where it actually is right now, physics gives you an answer that sounds less like science and more like madness. The electron is not sitting over there, waiting patiently for you to find it. In fact, the electron is not sitting anywhere. Not because your tools are too weak, not because your microscope isn't powerful enough, but because, before you measure it, the electron literally does not possess a single, definite position. This is not speculation. This is not a philosophical debate. This is the direct conclusion of the most precise mathematical framework ever created in science, and every experiment we've ever performed agrees with it. The electron exists in what physicists call a superposition. That word sounds technical, but its meaning is deeply unsettling. It means the electron is not confined to one location. It exists in many possible locations at the same time, not moving between them, not switching rapidly, actually existing in multiple possibilities simultaneously. It is not here. It is not there. It is both and neither. Your brain immediately tries to rescue itself. It wants to convert this into something familiar. You imagine a kind of fog, a blurry cloud, where the electron is physically smeared across space like smoke filling a room. But even that picture is misleading, because the electron itself is not physically stretched out. Whenever we finally detect it, whenever we force reality to give us an answer, the electron always appears as a single, indivisible point, one exact location, never half here and half somewhere else, never fragmented, always whole. So, what exactly was spread out before you looked? Not the electron, the possibilities. There is something called a wave function. It is not a physical object you can touch or see. It is a mathematical entity, but it is the most honest description of the electron that exists. The wave function does not tell you where the electron is. It tells you where the electron could be. In some regions, the wave function is strong. That means if you look there, you have a high chance of finding the electron. In other regions, it is weak. The electron might appear there, but it's unlikely. And in certain places, the wave function drops to zero. Absolute zero. If you search there forever, across billions of years, you will never find the electron in those locations. Not because it's hiding, because it does not exist there at all. And here is the part that truly breaks human intuition. Before you measure it, the electron is not secretly sitting in one of those high probability spots, waiting to be discovered. It is not a hidden object with a hidden address. It genuinely does not have a position. Its reality is not a point in space. Its reality is the wave function itself. The electron, in its purest form, is not an object. It is a pattern of possibilities. That's it. There is no tiny ball flying along a hidden track. No miniature planet tracing a cosmic circle. No secret location waiting to be uncovered. What exists is the wave function and the possibilities it describes. And this is where the familiar solar system image completely disintegrates, because that image doesn't just mislead you about position, it misleads you about motion itself. You were taught to imagine the electron orbiting the nucleus, moving in a clean, predictable loop, maybe fast, maybe unimaginably fast, but still following a path, still behaving like an object traveling through space over time. But that idea creates a fatal problem, because physics already knows what happens to charged particles when they move in circles. They lose energy. This isn't theoretical. This is one of the most well-understood principles in electromagnetism. Any charged particle that accelerates and moving in a circle is always acceleration. Even at constant speed must emit electromagnetic radiation. It leaks energy into the surrounding space in the form of light. It cannot help itself. It must radiate. So, if the electron were truly orbiting the nucleus like a planet, it would constantly be losing energy, bit by bit, moment by moment, each loop draining a little more of its motion away. And as it lost energy, its orbit would shrink. It would spiral inward, closer, faster, tighter, until eventually there would be nothing left to sustain the motion. The electron would collapse straight into the proton. The atom would cease to exist. This isn't speculation. You can calculate exactly how long this process would take. The answer is horrifying. About 1/10 trillionth of a second. 0.0001 seconds. That's how long every atom in the universe should survive if electrons truly orbited like planets, which means every atom in your body, every atom in the air, every atom in every star, every planet, every galaxy, should have collapsed almost instantly after they formed. The universe, as you know it, should not exist. And yet, it does. Atoms are stable. They do not collapse. They do not spiral inward. They endure for billions of years. Which means one thing is absolutely certain. The electron is not orbiting the nucleus. Not in circles. Not in paths. Not in any classical sense at all. Whatever the electron is doing, it is something far stranger than motion. Atoms do not collapse. They persist. They remain intact. They build molecules, matter, planets, and you. So the electron cannot be orbiting in the way you were taught. At this point, your intuition tries one last escape. You think, fine, maybe the electron isn't moving in circles. Maybe it's just sitting there, suspended in place, held by the electric attraction between the negative electron and the positive proton, locked in position like a bead frozen in invisible glue. But that idea fails too, and it fails for a reason that cuts straight into the heart of quantum reality. Because if the electron were truly sitting still, frozen at a precise point in space, we would know two things with perfect certainty: its exact position and its exact momentum. Its position would be fixed. Its momentum would be zero, and nature does not allow that. This is not a technological limitation. It's not about microscopes or measurement precision. It's a law woven into the structure of reality itself. It's called the Heisenberg uncertainty principle. It says there is a fundamental limit to how precisely certain pairs of properties can exist. At the same time, the more precisely the electron has a defined position, the less defined its momentum becomes, and the more precisely its momentum is defined, the less defined its position becomes, not hidden, not unknown, undefined. This isn't because we lack information. It's because the information does not exist in the first place. So the electron cannot be orbiting like a planet. That would require a defined path, and it cannot be sitting still like a stationary object. That would require both precise position and zero momentum. Both possibilities are forbidden, which leaves you with an uncomfortable question. If it's not moving in a path and it's not sitting still, what is it doing? The answer is almost infuriating in its simplicity. It isn't doing anything. It is simply existing, not as a tiny marble, not as a miniature object, but as a wave function, a mathematical structure that encodes all the possible places the electron could appear if you tried to observe it. This wave function is not random chaos. It has structure. It has form. It obeys strict mathematical rules. Only certain shapes are allowed. Only certain energy levels are permitted. These allowed patterns are what physicists call orbitals. But the word orbital is dangerously misleading. It does not mean orbit. It does not mean path. It does not mean motion. An orbital is a region of possibility, a map of probability. The simplest orbital, the lowest energy state of hydrogen, forms a perfect sphere around the nucleus, not a shell, not a surface, but a gradual fading cloud. The probability of finding the electron is highest near the center and smoothly decreases as you move outward. There is no line tracing its movement. There is no trajectory you can follow, only a three-dimensional haze of potential. And when the electron has more energy, these patterns become even stranger. Some orbitals stretch into two opposing lobes like a dumbbell. Others form rings, hollow in the center like cosmic donuts. Some create intricate, multi-lobed structures that look more like abstract art than anything resembling a physical object. These are not shapes the electron physically occupies like a blob of matter. They are statistical landscapes. They are predictions. They are the fingerprints of pure probability. They tell you where the electron might appear when reality is forced to make a choice. And just when you think you've reached the limit of how strange this gets, nature takes one more step beyond your intuition, because the electron does not move between orbitals the way any normal object would move. It doesn't drift upward. It doesn't glide. It doesn't pass through the space in between. It simply appears somewhere else. One moment, the electron exists in one orbital, a specific pattern of probability, a specific energy. The next moment, without warning, without transition, it exists in a completely different orbital, a different pattern, a different energy, a different reality. This is what physicists call a quantum leap. The name sounds dramatic, but it's almost too gentle for what's actually happening, because nothing leaps in the way you understand leaping. There is no trajectory, no intermediate positions, no visible journey. There is only before and after. Imagine turning off a light in one room and instantly turning it on in another room across the house, without ever passing through the hallway in between, not moving fast, not moving invisibly, simply ceasing to exist in one place and existing in another. That is what the math describes. And more importantly, it's what experiments confirm. Electrons absorb energy, and their wave function suddenly reshapes itself into a higher energy orbital. They release energy, and just as suddenly, they drop back down. These transitions produce the exact frequencies of light we observe in atomic spectra perfectly, matching the predictions. We can measure the result with absolute precision. But here's the part no one can explain. There is no known mechanism, no physical process that shows how the electron travels between those states. It does not move through space to get there. It simply changes. Reality itself updates. And that raises a deeper, more unsettling question. What is the electron, really? Your instinct tells you it must be a tiny object, a microscopic sphere, something with size, something with shape, something that exists in the same sense that a grain of sand exists, just much smaller. but experiment after experiment destroys that idea, because sometimes the electron behaves exactly like a particle. When you measure it, it appears at a single point, localized, discrete, whole. But other times, it behaves like a wave. It spreads out. It bends around obstacles. It creates interference, patterns, ripples of probability, interacting with themselves. In certain experiments, a single electron can pass through to separate openings at the same time and interfere with its own possibilities, producing patterns no classical particle could ever produce. It behaves like something extended, something fluid, something that cannot be confined to a single point until you force it to be. So, which is it? A particle or a wave? The answer is neither, and both are wrong. The electron is something else entirely. It is a quantum object, a category of existence that has no true counterpart in the everyday world. Something that only reveals fragments of its nature depending on how you look at it. When you measure its position, it responds like a particle. When you allow it to evolve freely, it behaves like a wave. But underneath both behaviors is the deeper truth. When you are not observing it, the electron is fully described by its wave function. And that wave function evolves smoothly over time. It spreads outward. It overlaps with itself. It creates intricate patterns of constructive and destructive interference, like ripples on a pond interacting in complex harmony, not because the electron is physically splitting apart, but because its reality is not confined to a single outcome until the moment observation forces it to choose. But here is where reality delivers its final blow to common sense. As long as you don't look at the electron, it exists as a spread-out wave function, a cloud of possibilities, a pattern of probabilities. It has no single location, no definite point, but the instant you measure it, everything changes. Every single time we detect an electron, we never see a cloud. We never see something smeared across space. We never see something partially here and partially there. We see one point, one tiny, precise, localized event, a single flash on a screen, a single click in a detector, a single, undeniable outcome. The wave function, which was once spread across space, suddenly collapses into one exact location, not gradually, instantly. One moment, the electron is described by a range of possibilities. The next moment, reality selects one answer and erases all the others. This process is called wave function collapse. And here's the part that has haunted physics for nearly 100 years. No one knows what actually causes it. No one knows what truly qualifies as a measurement. Is it a detector, a photon interaction, a conscious observer, or something else entirely? No one knows what physically happens to the wave function when it collapses. Does it disappear? Does it change form? Does it still exist somewhere, hidden beyond what we can observe? The equations predict the outcomes perfectly. The math works with flawless precision. Every experiment confirms the predictions. And yet, we do not have a clear picture of what reality itself is doing behind the scenes. This is known as the measurement problem, and it remains one of the deepest unsolved mysteries in all of science. Some physicists believe the wave function never truly collapses. Instead, they argue that every possible outcome actually happens, each in its own separate branch of reality, a vast network of parallel worlds, constantly splitting apart. Others believe there are hidden variables guiding the electron, invisible mechanisms beneath the surface. Others still believe the collapse is a real, physical process, something that happens objectively, whether anyone is watching or not. These ideas have names, many worlds, pilot waves, objective collapse theories, but they are interpretations, stories we tell ourselves to make sense of equations that refuse to explain their own meaning. The predictions are correct. The mechanism is unknown. And now, as if this wasn't already strange enough, things become even more disturbing when you add more electrons. Hydrogen has 1 electron, helium has 2, carbon has 6, iron has 26, and none of these electrons are orbiting like planets. They all exist as wave functions, overlapping, interacting, forming a shared quantum structure around the nucleus. But here's the detail that breaks one of the most fundamental assumptions you have about objects. Electrons are not just similar, they are identical in the deepest possible sense. Not identical like two copies of the same model of phone. Not identical like two grains of sand that happen to look alike. Identical in a way that removes individuality completely. There is no label you can attach to one electron that distinguishes it from another. No hidden serial number. No internal tag. No distinguishing feature. Electron number 1 and electron number 2 are not separate entities with matching properties. They are indistinguishable manifestations of the same underlying reality. If you swapped two electrons, nothing observable would change. Not because the change is too small to detect, but because, at the deepest level, there is no meaningful difference between them to begin with. They are not separate things in the way your intuition expects. They are part of a unified quantum system. And when you describe multiple electrons together, their combined wave function obeys strict rules so precise that even swapping their positions introduces a subtle mathematical transformation, a negative sign that encodes the fundamental symmetry of nature itself. This isn't a minor detail. This is the rule that explains why matter has structure, why atoms have layers, why electrons stack into distinct orbitals instead of collapsing into the same state, why chemistry exists, why solid objects resist passing through each other, why you are solid instead of collapsing into a dense point. The stability of the entire physical world emerges from these invisible quantum rules, and beneath it all lies a truth that is almost impossible to accept. The universe, at its foundation, is not made of solid objects. It is made of probabilities, patterns, and rules that only resolve into definite reality when forced to reveal themselves. This rule has a name, the Pauli exclusion principle, and it is not just another technical detail buried inside physics textbooks. It is one of the most important rules in the entire universe. It is the reason matter has structure. It is the reason atoms don't collapse into featureless points. It is the reason chemistry exists. It is the reason you are not falling through the floor right now. The principle is simple to state, but its consequences are enormous. No two electrons can exist in exactly the same quantum state at the same time. That means an electron cannot occupy a state that is already taken. If one electron exists in a specific orbital, with a specific energy and a specific spin, every other electron is forbidden from copying it perfectly. They must be different. They must occupy different patterns. They must spread out. This is why electrons form layers around atoms instead of collapsing into a single dense cloud at the lowest possible energy. It's why atoms develop structure distinct shells, distinct orbitals, distinct configurations. It's why hydrogen behaves differently from carbon, why carbon behaves differently from iron, why the periodic table has patterns instead of being a meaningless list. Electrons stack into organized layers, each one forced into its own unique quantum identity. Without this rule, everything would fall apart, literally. If electrons were allowed to occupy the same state, they would all collapse into the lowest energy configuration. Every atom would look the same. Every element would behave the same. There would be no diversity, no bonding, no molecules, no chemistry, no biology, no complexity, no life. The entire universe would reduce to a uniform, lifeless simplicity. And here's the part that makes this even more unsettling. We don't know why this rule exists. We know how to describe it mathematically. We know how to use it to make incredibly precise predictions. Every experiment confirms it without exception. But the deeper reason, the underlying cause, remains unknown. Why does swapping to identical electrons alter the mathematical structure of reality? Why must nature obey this strange restriction? We don't know. It is simply a law the universe follows. And if you thought the nucleus, at the center of the atom, would finally bring you back to something solid and understandable, it won't. Because protons and neutrons, the particles that make up the nucleus, are not fundamental either. They are built from something smaller, something even stranger. Each proton and each neutron is made of 3 quarks, tiny entities called up quarks and down quarks, bound together by the most powerful force in nature, the strong nuclear force. This force is carried by particles called gluons. But gluons don't behave like glue in any ordinary sense, and quarks don't behave like tiny balls sitting neatly inside the proton. They do not stay still. They do not occupy fixed positions. They exist in constant motion, in constant interaction, in a restless, dynamic state that defies any simple picture. Inside the proton, there is no static structure. There is only energy, fluctuating, interacting, emerging and disappearing in a continuous quantum storm. Inside the proton, there are no tiny spheres sitting quietly. There is no miniature solar system. There is no static structure you could freeze and examine. What exists instead are quantum fields, restless, fluctuating, alive with constant activity. The quarks inside the proton are not like marbles trapped in a container. They are not fixed objects with defined edges. They are excitations of deeper fields, continuously interacting with another field called the gluon field. Gluons are not passive connectors. They are dynamic carriers of the strongest force in nature, constantly exchanged, constantly reshaping the internal structure. The proton is not a container holding three quarks. The proton is a pattern, a stable pattern of vibration in the underlying quark and gluon fields. And here is where reality becomes even more counterintuitive. If you measure the mass of a proton, almost none of it comes from the quarks themselves. The quarks on their own are nearly massless. Instead, the mass comes from the energy of their interaction, from the motion, from the tension in the gluon field, from the confined energy of the system itself. Mass is not coming from stuff. Mass is coming from energy. This is Einstein's equation made real. Energy and mass are not separate things. They are different forms of the same underlying reality. When energy is trapped in a stable configuration, it becomes what you perceive as mass. So when you ask what a proton is made of, the honest answer is not particles in the traditional sense. It is energy organized into a stable structure, and even the nucleus itself, which seems like a tight cluster of protons and neutrons, is not made of objects touching each other like billiard balls. They are held together by another layer of interaction, a residual effect of the strong force carried by particles called pions. These pions themselves are not fundamental. They are also made of quarks. They are also excitations of fields. At every level you examine, the same truth repeats. Not objects, fields, interactions, patterns. So step back and ask the original question again. What is actually inside an atom? Not tiny balls, not miniature planets, not solid objects orbiting a central core. What exists inside an atom are quantum fields. The electron field, the quark field, the gluon field, the electromagnetic field. These fields are not confined to the atom. They extend everywhere, through the atom, through you, through the vacuum of space. They exist at every point in the universe, even where you think there is nothing. What you call an electron is not a standalone object. It is a localized excitation in the electron field, a ripple, a vibration, a temporary concentration of energy in a deeper, invisible medium. The atom itself is not a physical thing in the classical sense. It is a stable pattern formed by multiple interacting field excitations, a dynamic structure held together by relationships, not by solidity. And at the deepest level we currently understand, there are no solid objects at all. There is no indivisible stuff. There are only fields, mathematical entities that assign values to every point in space and time, values that evolve according to precise equations, values that interact, overlap, and organize into patterns stable enough to form the illusion of matter, what you perceive as physical reality. Every object, every surface, every sensation is the visible consequence of invisible fields vibrating in structured harmony. Matter is not made of things. It is made of behavior. These fields assign numbers to every point in space and time, and sometimes under the right conditions those numbers form stable disturbances, localized vibrations, concentrated ripples. We call those ripples particles, not because they are truly tiny objects, but because they behave like objects when we observe them. And I know what your mind is doing right now. It's resisting this. You want there to be something solid at the bottom of everything, something permanent, something you could point to and say, that's the final layer. That's what reality is made of. But there is no final object waiting at the bottom. There are only equations, symmetries, conservation laws, mathematical relationships that somehow, against all intuition, give rise to the illusion of solidity, the illusion of matter, the illusion of permanence. Your body feels solid. The chair beneath you feels solid. The floor feels unyielding. But beneath that sensation, there is no hard surface. There are only quantum fields interacting, stabilized patterns, energy configurations obeying invisible rules. Every atom in your body is a dynamic structure, constantly fluctuating, constantly maintained by forces and principles like the Pauli exclusion principle, preventing collapse, maintaining separation, preserving structure. Nothing is frozen. Everything is active. Everything is alive with motion at scales too small for you to perceive. And here's another idea that people often repeat but rarely understand. You've heard that atoms are mostly empty space. But even that statement is misleading, because empty space does not mean nothing exists there. The quantum fields are still present. They do not disappear. Even in a perfect vacuum, those fields remain. They fluctuate. They vibrate. They generate temporary disturbances called virtual particles, appearing and disappearing too quickly to directly observe. The vacuum itself is not empty. It is restless. It is active. It is full of potential. And the electron's wave function extends throughout the atom. It doesn't occupy a single point in the classical sense. Its probability amplitude exists across the entire atomic structure. The electron is present as a distribution of possibilities, not as a tiny sphere sitting in one place. So when you press your hand against a table, what are you actually feeling? Not particles colliding, not objects touching. You are feeling electromagnetic repulsion. The electron fields in your hand are interacting with the electron fields in the table. These fields resist overlap. They push back. The Pauli exclusion principle prevents electrons from occupying identical states, reinforcing that resistance. This resistance is what you interpret as solidity. But no actual contact occurs. No surface truly touches another. There is only interaction. Fields pushing against fields. Now consider the scale of all this. The nucleus at the center of the atom is incredibly small, about 100,000 times smaller than the atom itself. If you scaled the nucleus up to the size of a marble, the entire atom would expand to the size of a football stadium, and somewhere within that enormous volume of space, defined only by probabilities, exists the electron. But here's the part that completely breaks classical intuition. As far as every experiment can tell, the electron itself has no size, none. Every measurement we've ever performed is consistent, with the electron being a true point. No radius, no structure, no internal surface, a point with 0 dimensions. And yet, this point-like entity is associated with a region of space vastly larger than itself, a region defined not by physical boundaries, but by the reach of its wave function. How can something with no size occupy space? It can't, not in the way objects occupy space, because the electron is not an object in the classical sense. It is a localized expression of a field, a point of interaction, a place where possibility becomes reality when you force it to reveal itself. And this is the moment where intuition finally fails completely, because the deeper you go, the less reality resembles anything your brain evolved to understand. And yet, despite all this strangeness, nature continues to surprise. Let's make it even more counterintuitive. Let's talk about spin. Electrons have a property called spin. It behaves mathematically, like angular momentum, as if the electron were rotating on its axis. But here's the catch: the electron cannot actually spin. It's a point particle. A point has no size, no extent, nothing to physically rotate. And yet, somehow, it possesses angular momentum. This angular momentum is intrinsic. It does not come from motion in space. It is just a fundamental property of the electron, like its charge or its mass. We call it spin because it obeys the same mathematical rules as angular momentum. But it is not real rotation. It is something entirely alien to our everyday intuition. Spin is quantized. Every electron has spin 1/2. If you measure its spin along any chosen axis, you always get one of two results, up or down, never anything in between. And before you measure it, the spin doesn't point in any definite direction. It exists in a superposition. And once you measure along one axis, the spin along perpendicular axes becomes completely uncertain. Why does it behave this way? No one knows. There is no classical analogy. No everyday object behaves like this. It just is how spin works. The electron's energy levels are just as alien. In an atom, an electron cannot have just any energy. It can only occupy certain discrete energy levels. Why? Because its wave function the same spread-out probability pattern we've been discussing must fit around the nucleus in a way that is mathematically self-consistent. Think of it like a vibrating string. A string cannot vibrate at any arbitrary frequency. It can only resonate at certain fundamental frequencies and harmonics. The electron's wave function is similar. Only certain wavelengths are allowed. And energy is related to wavelength, so only certain energies are allowed. When the electron jumps from one energy level to another, it emits or absorbs a photon with exactly the energy difference between those levels. This is why atoms emit light at precise wavelengths. Why hydrogen has its characteristic red line, blue line, and others in its spectrum. Each line corresponds to a precise quantum jump. We can measure these lines with astounding precision. We can predict them with incredible precision. Quantum mechanics gets the numbers right to 10, 12, even 14 decimal places. The theory works perfectly. The predictions match experiments exactly. But why are energy levels quantized? Why does nature insist that electrons only occupy specific energies? The math tells us. The experiments confirm it. But the deeper reason, we have no answer. There is no classical explanation. No mechanism that fits into our everyday picture of how things work. It just is. And the more we dig, the stranger it gets. Now, let's confront another fundamental reality. What happens when you try to actually look inside an atom? You might think, I'll just shine light on it, like a microscope, but that won't work. Visible light is useless at atomic scales. Its wavelength is far too long bigger than the atom itself. To probe the atom, you need something with a much shorter wavelength, something far higher in energy. X-rays, electrons, gamma rays, these are the tools physicists use. But here's the unavoidable catch. The moment you use a high-energy probe to examine the electron, you disturb it. You alter its state. You change what you're trying to measure. This is not a flaw in your instruments. It is not a technological limitation. It is fundamental. At the quantum level, there is no such thing as passive observation. There is no way to look without interacting. Observation and disturbance are inseparable. The act of measurement does not merely reveal reality, it creates reality. This is why we cannot say where an electron really is before measurement. It is in hiding. It doesn't have a location in the classical sense. The very property of having a definite position does not exist until we perform a measurement that produces it. Before measurement, the electron is fully described by its wave function, a superposition of possibilities. After measurement, one possibility is realized. One outcome becomes definite. The measurement does not uncover a pre-existing reality. It transforms a fuzzy, probabilistic state into a specific fact. So, what is truly inside an atom? Not little balls, not tiny planets, not classical particles, not even objects in the sense you intuitively understand. What exists is a mathematical structure, a wave function, a solution to the Schrödinger equation, a pattern of probability amplitudes that tells you what you might observe if you look, but does not describe a definite reality when you aren't looking. The atom is a quantum system, and quantum systems behave in ways that defy common sense. They exist in superpositions. They carry properties that are inherently uncertain. They cannot be visualized in any conventional way. You cannot picture the electron orbiting a nucleus or protons glued together. There is nothing to picture. The wave function is not a physical wave in ordinary space. It exists in an abstract mathematical arena called Hilbert's space, a space of possibilities. It is a collection of complex numbers that encode probabilities. And from these numbers, through the strange rules of quantum mechanics, the universe emerges. Solid tables, glowing stars, the molecules in your body, they are all manifestations of these abstract probabilities. At the deepest level, reality is not made of objects. It is made of mathematics, patterns, probabilities, fields, and somehow, astonishingly, from these abstract structures comes everything you think of as real. And here's the final, most unsettling truth. At its core, the atom is information, not substance. There are no tiny billiard balls, no miniature planets, no solid building blocks hiding beneath the surface. What exists is an abstract, mathematical structure, a wave function, a pattern of probabilities, a set of rules encoded in numbers that evolve according to the Schrödinger equation. Yet from this abstraction, the entire physical world emerges. Chemistry, biology, consciousness, your own body. All of it arises from patterns in quantum fields, governed by equations that defy intuition but work with breathtaking precision. From math comes matter. From numbers comes reality. This is what is really inside an atom, not particles, not stuff, not anything tangible in the everyday sense. Math, pure, abstract, beautiful, incomprehensible math. And if that leaves you unsatisfied, if you still ache for something more solid, more real at the bottom of existence, I have to be honest, the universe doesn't care. It does not conform to your expectations. It does not bend to human intuition. It is what it is. And what it is far stranger than anything you ever imagined. Reality, at its deepest level, is not made of things you can hold or see. It is made of patterns, possibilities, and the elegant, unyielding logic of the cosmos itself. The world you experience, the tables, the stars. The life around you is the emergent shadow of invisible, mathematical patterns dancing at scales you can barely begin to comprehend. And that, my friend, is the astonishing, mind-bending truth about what's really inside an atom.